Hello everyone, good evening all. As you all can see, we are conducting a masterclass today. It's a live interactive class. You all would be able to see on your screens the topic for today, which is quadrilaterals, and also it is in relevance or is specifically for children who are in grade 7 and in grade 8. So other children can also join the session. There is, absolutely no issue, because those of you who would be coming to grade 7 and grade 8, this might be really very useful to you all, because you'll be learning something very, very new and for the first time. And those of you who are in higher grades, if you're a part of this masterclass, that also is great, because you would be touching upon, some basics and some core concepts which you've already learned. So it would be more like a revision. So we'll be starting very shortly, in few minutes. In a couple of minutes, we would be starting with our masterclass. You all can see the topic is quadrilaterals. Until then, what you all can do is go grab a pen and a notebook for yourself, because as I said already, that we would be touching on some very core concept of quadrilaterals, which forms, quite an important part in geometry. So you can all jot down important points, important formulas, if at all any. Also, as we would be solving some interesting problems, that might come handy. So do get yourself a pen and a paper or a notebook to write down everything important that you find, interesting in today's class. So we'll be starting very shortly. Until then, that's what you can do. All right, so here we begin with our today's masterclass. Before we actually dive in to the masterclass and start with the topic of quadrilaterals, let me just give you, a quick introduction about this whole masterclass. So these are all live sessions which happen, and these are quite interactive. You all can be a part of it. You all can ask questions, and these are basically for children who are, who fall in the category of K to 8 till grade 8. And these live sessions, these master classes, on an average, happen thrice a week. That is 3 times a week. Also, at times we include quiz, so it might go like 4 days a week if the quiz is also inclusive in that. So on an average, 3 times a week. And to know which are all the days that we are conducting the master classes, which are all the topics that we are conducting the master class on, and for which specific grade is it, what you all can do is follow the calendar, the weekly calendar, which gets shared on the WhatsApp group, which you all are a part of. So you can, keep a check on the weekly calendar, which gets shared, week on week basis. Every week there is a new calendar that gets shared. You would get all the information there, which are all the days the master classes would be happening, what are all the topics, and on which particular day is it for which specific grade. So if you're interested only in attending your specific, grade relevant classes, you can go according to the weekly calendar. So that's about the live sessions. Now, some best practices for the masterclass is what you should also keep in mind. All you have to do is be an active participant. By active participant, you should be listening very thoroughly and very carefully to what is being discussed in the masterclass. Also, take notes, for which I've already asked you to get a pen and paper for yourself. Whatever important you feel, you should be noting that down, jotting that down in your notebook. Then ask only the relevant questions. Okay, so like do not indulge, talking amongst yourselves in the chat box. Whatever questions if you have, like even between the master class, if at all, if you have any, please do put it in the chat box, in the comment box, and definitely we will be reverting to all the relevant questions that come in the chat box. So that's what you do. And also, as in mind, we would be, posing some questions, some practice problems. Be enthusiastic and put an effort to solve those problems. We'll definitely be discussing the solutions to those, but all we need to do is to practice. So these are some best practices that you can follow to, to get the maximum out of, the maximum benefit out of these master classes. Now, what all are we going to cover in today's class? As I've already discussed, the topic, as you all saw, is quadrilaterals. What in quadrilaterals? Because this class would not be very long, so we'll see what all are we going to touch upon. So we'll be having a quick introduction to quadrilaterals. Then we'll have properties of a quadrilateral, and then different types of quadrilaterals. So that's very, very basic foundation, core concepts of quadrilaterals. So these are the three important things. That is what we're going to cover. Based on these three key points, we would be solving some problems, some interesting, fun problems, which you all also can try and quickly give answers to. So this is what we're gonna do. So we will be starting very shortly, and by now I think most of you have joined. So those of you who are joining us for the first time, for the very first time, this is Neha Chauhan here. I am a subject matter expert at Cuemath, and I'll be the teacher. I'll be conducting the master class today. So feel free to reach out to me. In case if you have any questions, any doubts, please put it in the chat box, and we'll pick it up from there. So here we begin with the very first topic, subtopic in the topic of quadrilaterals, which is introduction. Now, there are different definitions that come to quadrilaterals, but how we would try to understand quadrilaterals is we'll break the term quadrilaterals. Okay, we'll break the term quadrilaterals and we'll try understand what does it exactly mean. Okay, from the word itself. So we'll not go into any definition, but we'll just try to understand the word in itself. So here you have the word quadrilateral. We can break it into two parts. Okay, you can basically break it into two parts. The first part being quad. Now quad you would have heard in a lot of places, like quadrants, quarters, all of that means four. So quad always means four. And then the second part that you get out of the word quadrilateral is lateral. Now lateral always means sides. So what did we understand from this? Quad means four, lateral means sides. So any closed shape which has got four sides is a quadrilateral. As simple as that. You don't have to go into any fancy definition, any complex definition of what a quadrilateral is. If anybody asks you what a quadrilateral is, in very simple terms, you can tell them any closed shape, okay, any closed flat shape, which has got four sides is a quadrilateral. Okay, so this is how very simple we can go with the quadrilaterals. Now, what all does a quadrilateral, what does it have? So a quadrilateral has got four sides, which we have already discussed, that is the edges, that comes in the word itself. Then it has got four vertices, that is the corners. Then we've got four angles, and then two diagonals. So let's just quickly see all of these things. So in very basic terms, what all it has got is, it's got four sides, then it's got four vertices, that is the corners, then four angles, and then two diagonals. Okay. Now this is what a quadrilateral looks like, if you all can see on your screen. So this is one side, second side, third side, and finally the fourth side. Okay, so these are the four sides, and now I'll mark the corners. So this is one corner, second corner, and then third corner and the fourth corner. So these are all the corners or the vertices that we are talking about. Then it has also got four angles. So angle 1, angle 2, angle 3, and angle 4. So these are all the four angles that we have in a quadrilateral. And then what we have is two diagonals. Now how do we get diagonals? You always join the opposite corners or the opposite vertices. So for the vertex A, the opposite vertex is C. So you would join those two to get one diagonal, and then likewise the other way. So here comes the first diagonal. We're joining the opposite vertices D and B. And the second diagonal, which we got by joining the vertices A and C. So I hope this must have been very clear with all of you of what exactly a quadrilateral is and what are the basic parameters that it has. Sides, four vertices, four angles, and then two diagonals. Okay. Now we'll go on to the next part of talking about the properties of a quadrilateral. So the very important one, very basic one, is the interior angle sum property. Now this comes in the same line as about the interior angle sum property of a triangle. So you all can tell me in the chat box, in the comment box, whether do you all know what is the interior angle sum property of a triangle? I'm not asking about quadrilateral, that is what we will discuss, but I'm asking you what is the interior angle sum property of a triangle? All of you who know the answer, please put it in the chat box. And let's see who all do really know this, because before quadrilaterals, what we learn in geometry is definitely triangles, and then we come to the part of quadrilaterals. Okay, so basically, the interior angle sum property of a triangle says, you see four angles here, right? Angle A, angle B, angle C, angle D. If you were to add all the angles, that is angle A plus angle B plus angle C and angle D, the sum of all the four interior angles in any given quadrilateral, no matter how its shape is, it's how distorted it is, whatsoever, the sum of all the interior angles of a quadrilateral is 360 degrees. Okay, so it's 360 degrees, no matter what, it's small, big, however it is. If it's a quadrilateral, the sum of the interior angles would be 360. Now, how do we get to prove this? Okay, so there are different proofs, which are available, but very easy one to understand comes through the interior angle sum property of a triangle, and that is why I was asking you all that. So basically, the key concept here is you divide the given quadrilateral into two parts. You divide it into two triangles. So what have I done here? I have basically divided into the given quadrilateral into two triangles. One is triangle A, B, C. The other is triangle A, D, C. Okay. Now the interior angle sum property of a triangle says the sum of all the three angles in any given triangle is always 180 degrees. So for one of the triangles, what we would get is, I'll just clear it off so that you can see it clearly. Okay, so for the first triangle, which we got on dividing the quadrilateral into two parts, triangle ABC, we in which we know that the sum of three angles is 180. And then for the other triangle that we have, the again sum of interior angles would be 180. So you put this up together, 180 this side, 180 the other side, and that gives you 360. So this is a very simple proof. How would you prove it? You divide the quadrilateral into two triangles. Each triangle has got the sum of its interior angles to be 180. You add 180 with 180, you get 360. As simple as that. So now, now that we have understood some very basic core concepts of what a quadrilateral is, what a basic quadrilateral is, we'll try out some problems. So I'll just quickly, reiterate whatever we have learned. A quadrilateral is a shape which has got four sides. It's got four corners, those are the vertices, then four angles, and then two diagonals. Also, the sum of all four angles at any given point in time would always be 360. That is the interior angle sum property of a quadrilateral. Now, the question here is, what is the measure of angle C? So this is the angle that you see here, the quadrilateral that you see here, of which three angles are given. I'll just tell you which are all the given ones. So angle A plus angle B plus angle C plus angle D. The sum should always be equal to 180 or 360 in a quadrilateral. It should always be equal to 360 degrees, of which three angles are already given in this, which is angle A, angle B, angle D, and angle C is not given, and that is the unknown. And that's what you need to find. What is the measure of angle C here? Now, all you need to do is plug in the values of the known angles and then solve for the unknown. So angle A takes the value of 54 degrees. Angle B takes the value of 76 degrees. Angle C is unknown, and angle D is 108. Equals 360 degrees. So quickly add up 54, 76, and 108. So 54 and 76 when added together would give you 130. and 130 plus 108 is basically 238. So 238 degrees plus angle C is equal to 360 degrees. Okay, you subtract both sides by 238, so you would get angle C is equal to 360 degrees subtract 238 degrees. So we'll do the subtraction here. So this is 360, 238, you get a 2 here, and then 5 subtract 3 is 2 again, and 3 subtract 2 is 1. So 122 degrees is the answer. So the measure of angle C is 122 degrees. Now, if you were to proof check, okay, if you were to check whether the answer that you have gotten is right or not, how will you do it? It's very easy once again. All you need to do is take all the 4 angles and add them up. So we have 54, 76, 122, 108. Now what will happen? You should get the sum of all the 4 angles to be equal to 360 degrees. If it doesn't come out to be 360 degrees, that means you have done some calculation mistake here. So 6 plus 4 is 10, 8 plus 2 is 10, 10 plus 10 is 20, so 0 to carry forward, 5 plus 2 is 7, 7 plus 7 is basically 14, 14 plus 2 is 16, 6, 1 carried forward, that gives you 3. So yes, we are getting the sum of all 4 angles to be 360 degrees. So our solution is correct, and the answer that we got, which is 122, is also correct. So that's how we solve it. We'll move on to the next question to try out. So because the first problem was the first one that we were solving, I helped you all a little bit. Now this is what you have to try on your own. Okay, so this says the angles of a quadrilateral are in the ratio 3 is to 5 is to 7 is to 9. All the 4 angles are in this ratio. Find the measure of each of these angles. That's what you need to do. The concept, or what you have to use here is the property of interior angle sum, property of a quadrilateral. Very easy, you all can try it and solve for it. What you need to find is the measure of each of the angles of the quadrilateral. Okay, so what you can do is you can consider, because you can take this as angle A, angle B, angle C, and angle D. You can consider these to be the 4 angles of the quadrilateral. And as these are in the ratio, you can consider angle A to be 3x, angle B to be 5x, angle C to be 7x, and angle D to be 9x. Now, if you would add up all of these angles, all the 4 angles, that would give you the sum as 360 degrees, because the sum of all the 4 interior angles of a quadrilateral is always 360 degrees. So we'll now add it up. 3x plus 5x is 8x, 8x plus 7x is basically 15x, 15x plus 9x is 24x. So 24x is equal to 360 degrees. Now we would divide both sides by 24 so that we can isolate x. Now this 24 and this 24 gets cancelled. We will, try to cancel out the common factors here. Divided by 4, so this is 90, because 9 4s are 36, so here would come 90, and 4 6s are 24, so 6 would come here. You can again further divide it. 6 1s are 6, and if we were to divide 90 by 6, you would get the answer as 15. Okay, so what have we got the value of x to be? We have found the value of x to be equal to 15 degrees. Now that we have found out the value of x, we can find the value of each of these angles. This was considered 3 times x, that is 3x. So 3 times 15 is 45. Then we had angle B to be 5 times x, so 15 times 5 is 75. Then we had C, which was 7 times 15, that is 105. And then 9x, that is angle D, is 9 times 15, which is 135. So these are all the 4 angles of the given quadrilateral. Wasn't that easy? All you were to do is to let all the 4 angles to be 3x, 5x, 7x, 9x, add them up together, set it to 360, find the value of x, and so you can find the value of all the 4 angles. Okay, so with this we will go on to the next part, which is different types of quadrilaterals. Okay, so we have learned a very basic quadrilateral, which was like the very basic of it. Now it's fun and interesting to know more about quadrilaterals and different types of quadrilaterals. So what will happen is each quadrilateral will have its own unique property, which is what differentiates itself from the other types of quadrilaterals. So that is what you have to always keep in mind, the different properties associated with different types of quadrilaterals. So we'll first see what are all the different types of quadrilaterals that we have. The first one being a parallelogram, the second one being a rectangle, third what we have is a rhombus, then we have a square, and then we have a trapezium, and then finally what we have is a kite. I think you all would be able to see a kite. So we have a parallelogram, a rectangle, a rhombus, a square, trapezium, and a kite. So these are the different types of quadrilaterals that we have. So here we will begin with the next part, which is, in particular, we'll try to know about parallelogram. Okay, so in a parallelogram, the first property that it has is opposite sides are parallel. Okay, so I'll mark it up that this side is parallel to this side is parallel to this side. That is what we mean, that the opposite sides are parallel to each other at all times. The next property that we have is opposite sides are equal. So I've already highlighted it. The blue marked ones are equal to each other. The red marked ones are equal to each other in length. Okay, the length would be same. Then the next property that we have is the opposite angles are equal. These are all the specific properties of only a parallelogram. Okay, keep in mind. So keep noting it down in your notebook, jotting in them, all the important points, all the important properties that you've come across. So opposite angles are equal. The ones marked in blue are equal. The ones marked in red are equal. Opposite ones. Then we have the angles which come adjacent to each other. I have just highlighted one. You might have different sets. So these two would always be adding up to 180 degrees. And finally, what we have is diagonals bisecting each other. Now, what do we mean by diagonals bisecting each other? As you would be able to see, I have blue ticked, two parts. Those two parts are equal halves. We know what a diagonal is. So whenever in a parallelogram, two diagonals intersect each other, they divide each other into two equal halves. वो दो आधे आधे हो जाते हैं, they become equal halves. So these are all some major properties of a parallelogram, which is unique in itself. Okay, this is uniquely present in a parallelogram. Opposite sides parallel, opposite sides equal, opposite angles equal, adjacent angles add up to 180, and then finally diagonals bisecting each other. Now that we have understood what a parallelogram is, we'll try to answer a few questions. You all can see the question on screen. It says two adjacent angles of a parallelogram are in the ratio 2:3. Find the measure of each of its angles. So it's pretty easy. We have just seen a property of the adjacent angles of a parallelogram. What do they add up to? They add up to 180. So we can consider the two angles to be 2x and 3x, because that is what the ratio has been given. And if you were to add these two, the sum would be equal to 180. So we then have 5x is equal to 180. So then x is equal to 180 divided by 5. So when you divide 180 by 5, so 5 threes are 15. You're left with, 5 threes are 15. You are left with 3 and 0, then 36 is what you get. So the two angles, 2x is 2 times 36, which is 72. And then you have 3x, that is 3 times 36, which gives you the answer as 108. And yes, they do add up to 180. So all what we did is we took the two angles to be 2x and 3x, added them together, and you would only be able to solve this problem if you know the property of the parallelogram that says the adjacent angles add up to 180. So we solved for x, we got the value of x to be 36, plugged in 2x and 3x. That is basically means 2 times 36 and 3 times 36. So 2 times 36 is 72. 3 times 36 is basically 108. So that's how we solve it. Okay. I hope it's clear with all of you. If at all, if you have any doubts, please keep posting it in the comment section, the chat section, and we will be able to answer to all of those questions. So here we move on to the next question, or the next concept that we have, which is of a rectangle now, which is another type of a quadrilateral. We'll see properties. Opposite sides are parallel and equal. So this is same as a parallelogram. Okay. Then the next is each angle is 90 degree. Each corner which you see is an angle which is measuring 90 degrees. So that is how it's different from a parallelogram. In a parallelogram also we have opposite sides parallel and equal, but we do not have angles to be specifically being equal to 90 degrees. This is specifically in a rectangle. All the 4 angles are 90 degrees. Okay. Whenever they say a rectangle would mean that all the 4 angles are 90 degrees. There is no exception. Now, the third one being diagonals are equal. Okay, so opposite sides are parallel and equal. Each angle is 90 degree. Diagonals are equal. Now that we've seen the properties of a rectangle, we'll solve very basic problem. Okay, here it says, 2 sides of a rectangle are in the ratio 4:3. If its perimeter is 56, find the lengths of its diagonals. So we've already worked on perimeters and areas. I think you all must be aware about it. So you should be able, I'm drawing a rectangle for you all. Let's also draw a diagonal to it. So this is from one vertex to another vertex is the diagonal. Okay. Now, the question is like, whenever you see such word problems, break it into parts and then try solving it. It says 2 sides of a rectangle are in the ratio 4:3. So we any which ways know that this side is equal to this side is equal to this side. So they're basically talking about 2 different sides of 2 different lengths. So we can consider this to be 4x and this to be 3x. So then this will also be 3x and this will also be 4x. Perimeter is 56. What do we mean by perimeter? When you add up the outer boundary, the total length of the outer boundary of any shape, that gives you the perimeter. Here you will be adding all the 4 sides. So we have 3x plus 3x being 6x, 4x plus 4x being 8x equals 56. Okay, now 6x plus 8x is 14x. 14x equals 56. You would divide both sides by 14 to get the value of x. 14 gets cancelled here. 14 times 4 is 56. So you've got the value of x to be equal to 4. Now that we have gotten the value of x to be 4, this is the value of x that we've got. We will need to find the exact lengths of, the length and the breadth, the width of the rectangle. So 4 times 4 is 16. So this side becomes 16. 3x. So this becomes, 3 times 4, which is 12. Now, how would you find the length of the diagonal now? So as this is always 90 degrees, this entire triangle, 12, 16, and this orange line, which is a diagonal, is a right angle triangle. So you can make use of the property or, the theorem, which is the Pythagoras theorem. So that basically tells you the sum of the squares of the 2 legs of the right angle triangle equals the square of the hypotenuse. So this would be, we take it as the unknown, let's say y. So 12 squared plus 16 squared is equal to y squared. Now 12 squared is 144 and 16 squared is how much? So you all can tell me what is the square of 16 and then what will be the value of y. So the square of 16 basically is 256 equals y squared. Now if you were to add 144 and 256, you get the sum to be 400 equals y squared. Now we're not interested in knowing y squared. We want to know what y is. So you would find the square root of 400, which is How would you find? I'll tell you how to find the square root of 400. You can write it as a product of 4 times 100. Now both of these are perfect squares. Square root of 4 is 2. Square root of 100 is 10. So 2 times 10 is 20. So the length of its diagonal is 20. Okay. So that's how you solve this problem. I hope this is clear with everyone. If at all any doubts, please put it in the chat box and we'll be reverting there. Okay, so let's quickly go on to the next type of different type of a quadrilateral, which is a rhombus now. So again, opposite sides are parallel and equal. Also, it doesn't only mean, I'll just tell you, it doesn't only mean that the opposite sides are parallel, but also, so this side is parallel to this side. But the length of all 4 sides is equal. If this is A, this is also A, this is also A, and this also is A. Okay, so that's how you see a very basic difference from a parallelogram to this. All the sides are parallel and equal, but like opposite sides are only parallel. ये इससे parallel है, ये वाला इससे parallel है, और चारों sides जो है वो equal है. All the 4 sides are of equal length. So that's what we have as the first property in a rhombus. Then the second is opposite angles are equal, highlighted ones, and the diagonals bisect each other at right angles. Okay, you see this red marked angle, that is basically showing, whenever you see an angle marked in a square box kind of a thing, that means it's a 90 degrees angle. So the diagonals of, so far we didn't see, any of the angles, bisecting each other at 90 degrees, but in a rhombus, diagonals bisect each other at right angles. So all the angles would be 90 degrees. So with this, we go on to trying out some, I hope you all have jotted down the important properties of, with the rhombus. Opposite sides are parallel, all 4 sides are equal, opposite angles are equal, and then finally, the diagonals will be bisecting each other at 90 degrees. So based on those properties, we have a question for you all. You all can read it. It says, ABCD is a rhombus whose diagonals meet at a point O. If angle OAB is equal to 30 degrees, find the measure of angle OBS. So we'll have the figure for you all here on screen. So you can read the question, try out the problem. Very easy, it's just like 1 or 2 steps. It's a rhombus. They've given you the measure of one of the angles OAB to be 30 degrees. And they're asking you to find the measure of OBA. I'll highlight OBA for you all. OBA, you always go in the order of how the angle has been named. So O here, B here, A. So this is OBA. This is what you need to find. What's the measure of this angle? Okay. How would we do it? We know that the diagonals of a rhombus intersect each other at 90 degrees. So this is 90. Now we are talking about triangle OAB, where there are 3 angles, angle O plus angle A plus angle B. And if you were to add all 3 angles, they would add up to 180 degrees. That is the interior angle sum property of a triangle. Angle O is 90 degrees, what we understood from the property. Angle A is already given, which is 30. Angle B is to be found 180. So 90 plus 30 is 120 plus angle B is equal to 180. You would subtract 120 from both sides. You would get angle B is equal to 180 subtract 120, which is 60 degrees. So 60 degrees is the correct answer to this question. Okay, this angle is measuring 60 degrees. Wasn't that easy? Right? So in quadrilaterals, it's really very important to know all the properties. If you know them all, you're halfway through. And after that, what you need to do is practice some problems and then you're good to go. So just know what quadrilateral is, what different types of quadrilaterals are, what their specific uniqueness in terms of properties. Practice some problems and we are good to go. Next, we will go on to the next type of a quadrilateral, which is a square. Opposite sides parallel, all sides equal, same as the rhombus. Or opposite sides are parallel, and then all sides are equal. If one side is 4, all sides would be 4 in length. Each angle is 90 degrees. That's what we didn't have in rhombus. That's how you differentiate between a square and a rhombus. The first part remains same for square and rhombus, but coming to the next property of a square, that's what we do not have there in the rhombus. In rhombus, all angles are not 90 degrees. Each angle is not 90 degrees. But specifically here in square, we do have like that. Diagonals are equal. Okay, so diagonals are equal. Now that we have know the properties of square, we'll go to the next part very quickly with trapezium. Okay, now trapezium is like a special type. A lot of children get confused here. Very basic property, just one single property of a trapezium is it's a four-sided quadrilateral, but it has got only one pair of parallel sides. So far, whatever we saw in special quadrilaterals, be it square, rhombus, rectangle, parallelogram, all of these had two pairs of parallel sides, okay, opposite ones. Here, the ones which I've highlighted are the only parallel ones. If you would see the other pair, they're not parallel. They would, at some point, if you would extend it, would go, on extending would go and intersect. So those are not parallel. So a trapezium is very basically, in definition, a quadrilateral which has got only one side to be parallel, one pair of sides to be parallel. Then you have another type which is called as the isosceles trapezium. Now, in isosceles trapezium, what you have is uh, one pair is basically parallel, which is highlighted in blue already. This one is parallel to this one. The remaining two sides, which are forming another pair, they are equal. Okay, so these two being parallel, and these two being equal in length. So that's the basic difference between a normal trapezium and an isosceles trapezium. I hope you would have gotten it. So this is with, this is what we have to do with trapeziums and isosceles trapezium. Next, we'll go on to try out some problems. Find the measure of the highlighted angle in the given quadrilateral. Okay. So the two arrows that you see in the quadrilateral, I'll highlight it for you all, means basically that these two sides are parallel to each other. These two arrows mean that EH, which is a side, is parallel to the side FG. Okay. Now you need to find the highlighted angle, which is this. Here comes the knowledge of parallels and transversals, which comes again in the very basic topic where we start the geometry with lines and angles. If you know parallels and transversals, you would be able to answer this question. Okay, so EH and FG are parallel to each other, and EG is acting as transversal. Okay, so the alternate interior angles are always equal in measure. So that would mean this angle here and this angle here are equal in measure. So we can set them to each other, that is, equate them. 3x subtract 14 is equal to 2x plus 4. You would get 3x subtract 2x, 14 plus 4, which basically gives you x to be equal to 18. Now that you have found out the value of 18, what would you do next? You would try to find the measure of this angle, which is 3x subtract 14. So 3 times 18 is 54. Subtract 14 is basically 40. So the measure of this angle is 40. What do you do next? You use the property of interior angle sum property of a triangle. So you would add 40 and 78, which is basically 118, and that needs to be subtracted from 180. Okay, so this gives you 2, 7 subtract 1 is 6, so 62. So this angle, which is the highlighted angle, is 62 degrees. So I'll tell you, there were basically 3 steps in this. First step being, you set these two angles equal to each other. 3x subtract 14 equals 2x plus 4. On doing so, you found the value of x. Okay, once you found the value of x, you found the value of the angle, which is 3x subtract 14. Once you found the value of 3x subtract 14, you use the property of interior angle sum property of triangle. In which triangle? In triangle EGH. And that gave you the measure of angle H, which was the question here. I hope the steps are very clear. The first step being, set these two, set both of these equal to each other, find the value of x. Then the second step was to find the value of this angle. Once you find that, you apply angle sum property of all the three angles being added up to 180, and so you find the measure of angle H, which came out to be, I think it was 62. Yeah, that's how you do it. Going next, what we have finally is a kite. So this is how a kite looks like. So, it's very different from all the other quadrilaterals that we have seen. The adjacent sides, which are connected to each other, are equal in length. So if you would see, the ones marked in red are equal to each other, and then the ones marked in blue are equal to each other. So the adjacent sides are equal, the adjacent pairs are equal in length. The next, so the two pair of sides, which are equal in length. Then the next, and each pair of two adjacent sides, okay, that's what we've already mentioned. Then you would see the angle which is here, which is the angle between the two unequal sides, would be equal to each other oppositely. I've already marked it up. So those are equal. The angles are equal where the two pairs meet. That's what I exactly said. The two unequal lengths where they meet, those two angles are equal to each other. So this is a little different. Kite is a little different. So you'll have to pay attention here, follow very closely. And finally, the diagonals, intersect each other at 90 degrees. Also, what it also has is that, one of the diagonals bisects the other. So the one which is getting bisected, I have already highlighted it. I'll show you again. So the first of all, they're intersecting each other at 90 degrees. Then this diagonal, okay, vertically standing one, is bisecting the horizontal diagonal into two equal halves. This is equal to this. So these are all the properties which are associated with the kite. So now we've come towards the end of the session. So I'll again reiterate on what these free trial classes are. So now that you have already seen the interactive free masterclass with us, we are to offer you a free trial class, which is here. There are so many children. All of you are here, and we do not get so much to pick up each one of yours doubts. So instead, or rather, what you can do is book yourself a free trial class of Cuemath, wherein it would be a 101 class. That is, it's just you and one more teacher. The teacher would exclusively, dedicatedly be for you. That's an expert teacher, and the teacher would be clearing all your doubts. You can ask them as many doubts as you have, how many ever times you want to ask those doubts. And what you will do is, once you book the trial class for yourself, you would come into the class and you will be working on some structured worksheets. Those worksheets are loaded with simulations. You'll be able to visualize the concepts. You'll be able to understand the concepts through visualization, through simulations. You'll be working on some puzzles, and the timings of these classes are quite flexible. Whenever during the weekends or during the weekdays you're free, you can always book yourself at that time a trial class, and then you can go ahead with it. Now, how do you do it? So this is what we're talking about, Cuemath live online classes. You can pick any topic of your choice and you can start learning it, as I said, through simulations. There are different ways of, understanding a concept. One way is definitely simulations, which is, I think, the best way that you can learn through. So these are some very simple steps that you can do to book yourself a free trial class. What you need to do is, step one, click on the link below, which has been highlighted or already given on the screen. That will also get shared in the chat box. So this is what you need to do. Click on the link given below. Then you will have to fill in some very basic details, that is your parents' name, email ID, and so on. Select the time and date for your class. Which day, that is which particular date are you free, and at what time are you free. So it's done. All you need to do is to click on the link and then fill up your basic details. Choose the day and the time that you're free in, and your class is booked. You would be able to experience, an interactive live session with a expert teacher. You'd be able to explore the, fun-loaded, simulation-loaded worksheets. So please do book yourself a trial class, and definitely go about it and see how interactive it is and how fun it is. So with this, it's a wrap for today's masterclass. I hope you all really enjoyed it, and I really thank you all for being a part of the masterclass today. Thank you all for coming. The weekly calendar for the next week would soon get shared on the WhatsApp group, so please do check it out. You can check it out on week basis as we share it, and you can see the topics that we would be covering next week. So hope to see you all soon next week, and wish you all a very, very happy and prosperous new year, because I think the next time we see each other would be in New Year. So wish you all a very, very happy new year. Do take care and see you all in the next masterclass. Thank you for joining us.